All right, folks, exercise 10.2. I'm just going to work through a few of these just for a bit of fun. Ignore the dogs barking in the background. Okay, now the key with all of this stuff is just to do one bit at a time. Just try and work out just one bit, and then to that one bit, add another bit, and then another bit, and so on. So let's have a play with some of these, and you'll see just how incredibly simple they really are. I mean, you look at something like this and you're thinking, oh my goodness, what do we do? But let's have a look. Well, this one is just as difficult as all of these ones. So in this one, again, we've got our isosceles triangle. Here it is, isosceles triangle. Here are the base angles of the isosceles triangle. Here is the angle at the apex. Here is the angle at the center, or the apex. And the angle, when I say the angle at the apex, I mean, of course, this angle here. But of course, 72 and the angle and the apex are angles on a line. So to find the angle at the apex, all we have to do is say, well, I know 172, and if I subtract 72 from 180, I'm going to get 108. So this angle here is 108 degrees. So 108 degrees. So the angle at the apex is 108. Now we know that the base angles have to be the same. So what have I got left? Or if I take 108 away from 180, I get 72 again, because this is also the exterior angle of a triangle, and the exterior angle of a triangle always equals the sum of the two interior opposite angles. So these two must be 72. If they're 72, well, let's divide them into two, and this must be half of that, and this must be the other half. Of course, half of 72 is 36. So x must be equal to 36 degrees. And that's how I would go ahead and find that one. And the others are all the same. Once you find one bit, you find the rest. So let's have a look at number 8. Number 8 looks hideous and scary, but in actual fact, it's very simple. Let's deal with one triangle at once. Well, this triangle here, and we know that's an isosceles triangle because that's a radius and that's another radius, so we've got two radii. There's a base angle of the isosceles triangle, and A is the other base angle of the isosceles triangle. So we've got A equals 40. Of course, now that we've found the 40, we've also got angles in a semicircle. Here we go. Angles in a semicircle, and there's my semicircle. Angles in a semicircle must add together to give 90. So we've got A, which is 40, so C must be 50. And the reason is because 40 and 50 equals 90. Of course, we also got B, and we could say we've got the angle at the center as twice the angle at the circumference. So B must be equal to 80. So B is 80. Other ways, of course, of finding B, a nice easy way would be to say, well, I know that C is 50, and C, and this angle here, this is an isosceles triangle again. Look, two sides, two base angles. That must be 50, that must be 50, and 50 is 100. What else adds together to give 180 would be 80. So B must be 80. And D, same story, like a beautiful isosceles triangle here. B, beautiful isosceles triangle to find D. So how are we going to find this? Well, we know this angle on the outside is 30, and we know all of the other angles. So we've got 40, and 40 is 80. This angle must be 100, because 100 plus 40 and 40 is 180. We've decided that B was 80, so we've got 180, plus we've got 30. So now we've got 180 and 30, which is 210. And we've got this bit here left. So we've got 200, we've got 360 minus 210, because we've got angles around a point add together to give 360. So I'm going to subtract what I know, which is the 100, the 80, and the 30, which is 210. Subtracting this gives me 150. So this must be 150 degrees. Sorry, I'm not writing it very well. There's 150. So it's very, very small on the sheet I'm writing. You can see how big my fingers are compared to the thing I've just written. So 150. So together, these two angles here must come to 30. And there's two of them, so 30 divided by 2. So D would have to equal half of 30, which is 15 degrees. And so on. Just work out one bit and work your way around. And that's all we need to do. Let's just do one more for a bit of fun. I like number 9. Here's number 9. Number 9, we've got... I've got my dogs outside, I think. I better go and rescue them in a minute. Okay, so I've got this nice isosceles triangle here. I got the angle at the apex is 50. And this angle here and here must together add together to give the rest. Well, 180 minus 50 is 130. So this must be 130 between these two. And 130 divided by 2 is going to be 65. So I've got 65 here, and x must equal 65. 2 65s is going to be 130. Now, same story here. I've got, this is a nice one. I've got the base angles here again. This is an isosceles triangle. Now, we don't know that this is angles in a semicircle. I don't think we can assume that. And these angles, I don't think, are vertically opposite. I can see this line is a bit different. It seems to go off on a slightly different route to this one here. So I don't think that could be what we think it is. But I think these are definitely angles on a line. So we've got angles on a line that looks like a straight line, whereas this does not look like a straight line with this one. Yeah, but that's angles on a line. We've got 80, which means this must be the rest of the angle on the line, which must be 100. Because angles on a line equal 180 degrees. And that's the angle at the apex. We've got base angles, 100 plus 80 must equal 40 each. So 40 and 40 and 100 is 180. Or you can say the angle at the outside of a triangle, the exterior angle, is equal to the sum of the two interior opposite angles. So these two must be 80. And for 80 divided by 2, y must equal 40 degrees. And there is my answer.